Hello and welcome to the Rational Functions and Simplifying Rational Expressions video. Now we're going to shift gears and actually also see some applications of our factoring in this video as well. Let's just go ahead and get started. So let's just note that a rational function, which we have seen before earlier in our session, is nothing more than a function r of x that can be written in a fractional form, okay, in this form where this top part is a polynomial and the bottom part down here is also a polynomial. All right, so basically a rational function is the ratio of two polynomial functions. And our objectives then for this video is going to be, one, to state the domain, and number two, reduce. So reduce the rational expression. So if you'll recall, I believe in class we talked about the difference between an expression or, if you will, a statement along with an equation. We'll kind of somewhat see a little bit of some of our equation stuff that is coming up. All right, so in this video, let's talk about domains of fractions. And remember, in fractions, we can never have a zero in the denominator. So our game plan is, given a rational function, to state the domain of a rational function is to find where all the zeros are in the denominator and say, well, the domain can be all the other values except for those values. So let's take a look, and let's suppose that f of x is equal to x plus 3 divided by x minus 3. So notice, as long as x is anything except for, and hopefully by inspection we can see by inspection that x can be any number except for 3. So notice that when x is equal to 3, we get a 6 on the top and we get a 0 on the bottom. And recall, we can never have division by 0. So let's just also recall one last time that 0 over anything is equal to 0. 0 over 0 is what we call indeterminate, something you may or may not have seen. You'll see that a lot later when you go into college algebra. And the idea is that if you have any number divided by 0, this is undefined. So we cannot have 0 in the denominator. So a lot of times, just to give us a procedure, what we'll do is just take whatever the denominator is, x minus 3, and instead of saying equals to 0, let's just say it cannot equal 0. And then just use our solving and just note that x cannot equal 3. So the idea is that the domain is all the real numbers except x equals 3. All right. So let's take a look at another one, and let's take a look at f of x equals x squared plus 16 divided by x minus 4, x plus 4. So let's just note, in this case, our denominator for us, luckily enough, is already factored. So when this thing is factored, all we have to do is just take the denominator, x minus 4, x plus 4, and note that this cannot equal 0. And from our solving by factoring trinomials and stuff like this, remember, this becomes a, placeholder a, this becomes b. Again, if you don't like the a's, this is square, and this is triangle. So remember, the only way that these two products can equal 0 is if one equals 0 or the other equals 0. So in this case, we get x plus 4 cannot equal 0, x minus 4 cannot equal 0. So solving, we get x cannot equal -4 and x cannot equal +4. So I believe in your MyMathLab, and I'm just going to bring this out on this part. I believe that your options are going to be something in the form, so you get a selector, the domain is the set X such that X is a real number and X cannot equal, and then there's a blank. And then your other option is going to be something like all real numbers, or in set notation, the set X such that X is a real number. Okay, so the idea is that you have this blank. So here we just put in 4 comma -4 is what you're going to be instructed to do. So you'll just choose this one and then fill in that blank over there and you'll be done, unless X can be any real number. So let's take a look at f of x equals x minus 1 divided by x squared plus 6x minus 7. All right, so our goal here is to find the domain of this rational function. And let's just recall that the domain is all the real numbers except where the domain is equal to 0. So we need to find those x values. So let's just note that we have this trinomial in the bottom. So when it's unfactored, all right, so we took a look at this type where this was factored. And then we took a look at this example, whereas in this example here, there was nothing to do. Everything was in factored form. So the first and second examples, the denominator in particular was already factored for us. So let's just note that since this is not factored, then we will employ all of our factoring techniques back from chapter 6. So x minus 1, if you haven't gotten sick and tired of factoring yet, well, you're going to be factoring for a long, long time. So we may as well go ahead and get these down. So let's just remember, when the leading coefficient is 1, the question now is what are the factors of -7 that add up to a +6. So I write my brackets, I put my x here, so I get +7 and a -1. So let's just observe that 7 times -1 is our -7, and 7 plus a -1 is our 6. So this checks out. So now all we have to do is take our denominator, so x plus 7 and x minus 1, and just say that this cannot equal 0. So this says that x plus 7 cannot equal 0, and x minus 1 cannot equal 0. So we get x cannot equal -7, and x cannot equal -1. So again, we'll just fill in these two blanks here. Sorry, not -1, +1. So x cannot equal -7, and x cannot equal +1. And again, you'll just go ahead and fill in the blanks. So that's really all there is to finding the domain. Is just remember, to find the domain of a rational function, it is all the real numbers except where the denominator is equal to 0. So the domain, all the real numbers except where x equals 0 in the denominator. All right, so now what we'd like to do is our objective 2 is to simplify. Simplify rational expressions. So let's just note that this is the same as reducing fractions. So this is the same as reducing fractions. All right, so to give a really quick numerical result, let's just suppose that you have 21 over 35. And let's just note that 21 can be rewritten as 7 times 3. And let's just note that 35 is 5 times 7. And let's just note that the 7's cancel out, and so we get 3 over 5. So reducing fractions, remember that? That was a lot of fun back in the day. So in this case, that's all we're going to do. All right. So to reduce rational expressions, the idea, again, that mathematical F word, factoring, comes into play. So let's just note that for our example 1, okay, example 1, we have 3x over 6x plus 9. And again, notice that on the top and on the bottom, what we want to do is to factor if possible. There's nothing to do on the top. So let's just note that on the bottom, there's the greatest common factor. So we get 3. So I get 2x plus 9. Or I'm sorry, 2x plus 3. And note that the 3's will cancel out. So I'm left with x over 2x plus 3. And that is reduced. Nothing else more to cancel out. So again, the bottom line is simplifying rational expressions for the most part just means factor the top and factor the bottom. So let's take a look at 17ab squared minus 12a cubed b divided by 6ab. So here we have this compound polynomial up top and just a single monomial on the bottom. Again, this is something we've already seen before. So we can rewrite this as 17ab squared over 6ab minus 12a cubed b divided by 6ab. And notice for this first fraction over here, this a cancels with this. There's no common factors between 17 and 6. And notice that this b cancels out with that squared. So notice that for the first fraction, we're left with 17b divided by 6 minus, come over here, we know that 6 goes into 12 2 times. A will turn the cubed into a squared, and the b's will cancel out. So here we get, looks like 2a squared. All right, and when everything cancels on the bottom, remember there's a pretend 1, and anything over 1 is always just whatever is up at the top. So not much else to do there. All right, so let's have a little more fun, kick it up a notch. So x squared minus 2x divided by x squared minus 4x plus 4. All right, so this is where we take a look at something like this. And again, just like we did with the number 21 over 35, we got to do some factoring. So notice at the top, there's nothing much to do. The only thing we can do here is factor out our greatest common factor. So I get x minus 2. And now down here, let's see if this thing factors. So I'll put an x here. I put my x here. So now the question is, what are the factors of positive 4 that add up to negative 4? And I think we can both agree that we're going to get a minus 2 in both of those slots there. So let's just double check. Notice that negative 2 times negative 2 becomes our positive 4, and minus 2 becomes our negative 4 when we add those together. So now we can go on this highly mathematical term, I say, go on our slashing spree. So we can cancel out the x minus 2's. So notice we're left at the top with the x, and on the bottom we get our x minus 2. Okay. So that is now fully reduced. All right, let's take a look at x cubed plus 1 divided by x squared minus x plus 1. And let's just note that x cubed minus 1, well, this is x cubed plus 1 cubed. Okay. So this is in our sum of cubed binomials. So we know that this is going to factor to x plus 1 times, and now it's going to be x squared minus, multiply the 2 together, so we get x, make sure we have that sign change, and then plus 1. So now the question is, does x squared minus x plus 1, does this factor? So again, since the leading coefficient is 1, we put those there. So here's a real simple test. Well, the factors of 1 is 1 and 1, and negative 1 and negative 1. So let's just note that 1 times 1 gives us our 1, and 1 plus 1 gives us 2, and we need a negative 1, so that's not going to work. So let's just note that negative 1 times negative 1 gives us our positive 1, and negative 1 plus a negative 1 gives us negative 2. So that means that this denominator polynomial is prime, so we can just write x squared minus x plus 1. So the top is factored, the bottom does not factor, but let's just note that this will cancel with this, so this leaves us with x plus 1, and now there's nothing else that we can do with that one. Okay. All right, so we got a couple more here, so bear with me. So 4x squared plus 19x minus 5 divided by 4x minus 1. All right, so let's take a look. The denominator, well, there's not really much to do with our denominator, so I could just write 4x minus 1. But let's come over here and take a look at this top part over here. So let's just observe, if I take 4 and multiply that by negative 5, all right, 4 times negative 5, so this is going to give me negative 20. So the question now is, are there any factors of negative 20 that will add up and give me a 19? So I'm taking a look at 20 and negative 1 perhaps. So notice that 20 times negative 1 gives me this 20, negative 20, so that works. And notice that 20 minus 1 gives me the middle term that I'm needing. So I can rewrite this as 4x squared plus 20x minus x minus 5. Now at this point, I would like to make a comment based on some observations that I saw in class, because we know that right now we have 4 terms. We know we're going to imply our factor by grouping. Now if you'll go back, and please go back to some of the videos that we looked at earlier and some of the stuff that we've done in class, when we go to grouping, this is what I've seen. Okay, this is what I've seen. So 4x squared plus 20x, and then minus x minus 5. And this is incorrect, ladies and gentlemen. Do not do this. Okay, I can't bring this out any more clear than I am doing right now. Do not do this. So I'm going to put that in a red box. Please no longer do this. When we say factor by grouping, we're going to group the first 2 terms together. Okay, remember, this isn't a Google search. It's not a speed thing. Okay, it's not. Notice that when you group this way, notice we end up with a product. You cannot have a product. Since this right here is a subtraction, we got to be careful of our sign flippage. Minus, and then notice now I grouped the second 2 terms, x minus 5. Please observe the difference, and if you have to, pause this video, look at what you've been doing, look at what this is going on. All right, so we should not, and let's try to clear these problems up now. Okay, I'm sorry, this should be x plus 5. Thank you for catching that, by the way. I could hear you right now. So now we factor out the greatest common factor in our top grouping here. So here we're going to get 4x. So we get x plus 5 minus, and notice there's no common factor here, so x plus 5. So again, x plus 5, we can pull these out. So I have our 4x minus, and then notice there's that invisible 1 sitting right there, times x plus 5. Okay? Now I'm going to take this 4x minus 1 and put this up here times x plus 5. All right, and notice that this 4x minus 1 cancels with this, so I'm left with x plus 5. All right, so again, take a moment, go back, take a look at the factor by grouping, and make sure that you are okay with that. So for our last factoring one, so I'm going to get x squared minus x plus 72 divided by x squared minus 18x plus 81. All right, so here we have the ratio. Here we got two trinomials. Leading coefficient is 1. So let's go ahead and factor the top, factor the bottom. So going back up here to the top, notice we have an x and an x. So the question is, what are the factors of 72 that add up to a negative 8? So we know that, how about 9 times 8? But since I have a negative, so let's just make that 9 a negative. So we get negative 9 times 8 gives me my negative 72. Did I write that down right? Oops, this should be minus. Sorry. We got oops 1, so minus 1 for me. All right. So notice here, let's see. Yeah, this is what it should have been. Let me make sure I got my other one. So x squared minus 18x plus 81. Okay. Okay, so here we have, go ahead and let's just note that negative 72 is negative 9 times 8. So here we get our negative 72. And when I add these together, I get my negative x. So I get negative 9 plus 8. Okay. So coming down here to our bottom, we get x and x. So now we have 81. So we have a positive 81. So we know that 81, the factors are 9 and 9. But we have a subtraction. So what if we get negatives there? So notice that negative 9 times negative 9 gives us our 81. And negative 9 plus a negative 9 is our minus 18. So minus 9 and minus 9. So again, these guys will cancel out. So here we get x plus 8 divided by x minus 9. Okay. Sorry about that little oops there, the typo there. Oh well, I'll just go ahead and leave that in just to let you know that every once in a while, sometimes I can make an oops. However, few and often in between. Okay, so let's take a look at something like this. We're going to see this in our next video. And this is off by a negative. Okay, so how do we do an off by a negative sign? Off by a negative sign. All right, and we're going to see this on our next video. So we got a negative out front. So one of the first things we can do is attach the negative to the top part. Okay, and write it like this. So now what I can do is use the distributive property, and let's just note when I distribute this across the parentheses there, that I can rewrite this as negative y plus 2 divided by x plus 7. So this is known as an equivalent form. What the author is talking an equivalent form. All right. So let's just note that that's 1. And then the other says that I could just take these two and reverse them. So I get 2 minus y divided by x plus 7. And let's just note that this guy here is the second form. So a lot of times what we'll see is when we say we're off by a negative sign is we need to flip these two. For example, these two right here. So notice I have a 2 minus y. So the question is, how do I rewrite this as y minus 2? All right, so we're off by a negative, so we factor out a negative. The second thing we'll do is we can bring the negative down to the bottom. So I get y minus 2 divided by negative x plus 7. Okay, so in this case, I can rewrite this as y minus 2, and again, distribute the negative across, so we get negative x minus 7. So there's the third form. All right, or I can rewrite this as y minus 2 over negative 7 minus x. And there's the fourth form. All right, so just wanted to bring this to your attention. Again, we will see this again in our next video. All right, I hope this helps you out. And again, feel free to stop, pause, and rewind. And if you have any questions or any concerns, anything in this video, please go ahead and post those in your warm-ups. Thanks a lot. See you in class.